Okay, so we're going to look at our last conic section, which is the hyperbola. And you're going to see a lot of things that are very similar between ellipses and hyperbolas, starting with the definition of a hyperbola. So when we talked about an ellipse was defined as a collection of points in the plane, such that if you measure the distance to two fixed points from the edge of the ellipse and add the distance, it comes out to a constant. Well, with a hyperbola, we're going to measure the distance from a point on the hyperbola to two fixed points, and we're going to subtract the distances, and it will be a constant. Okay, so the only difference in the definition between yesterday and today is one word. We changed sum to difference. We'll look at a picture because I think that'll help it make more sense. So there's our hyperbola, and you'll notice that the hyperbola is in two separate pieces. Okay, it's not like an ellipse, a parabola, or a circle. Those are one piece. Hyperbola is always two pieces. They're not really called pieces. They have names, which we'll say in a minute. But what I want to look at here is line segment EC and line segment EB. It's the same two line segments we looked at with an ellipse. We're going to measure the distance from a point, which we're going to call E, to those two special points C and B, which are not going to move. As we measure the distance, you'll notice these two numbers are going to change. But if you look at the difference between those two numbers, it will always come out to 5.66. 5.66 is just the number for this hyperbola. Different hyperbolas can have different numbers, but this one is always 5.66. And when we say difference, yes, if I switch it, put this on the other side, all of a sudden the top number became bigger than the bottom. We're looking at the absolute value of the difference. Okay? So the absolute value always of the difference always comes out the same. So you can try that. Take 14.67, subtract 9.01, and you get 5.66. Any question on that? So that's the definition, and that's the picture that goes with it. There are two different ways we can draw a hyperbola. One way is with the pieces opening left and right. The other way is opening up and down. So it's very similar to an ellipse in terms of the number of cases. Okay, so next we'll go through all the vocabulary that we're going to use when we talk about hyperbolas. Some of it is similar to an ellipse, some of it's not. So the first thing is that those two fixed points are what we call foci. And we had those in an ellipse. And the foci are imaginary points inside the parts of the hyperbola. The hyperbola doesn't go through the foci. It wraps around it. Now yesterday we had a name for the line that went through the foci. Does anyone remember, what did we call that axis yesterday that went through the foci, went through everything? Yeah.
Major axis.
That was called the major axis. Today, the line that goes through the foci is called the transverse axis. And the way that I remember that it's transverse is, to me, transverse kind of looks like traverse. And if you traverse something, that means you go from one side to the other. Traverse it, you go across it. So the transverse axis connects the two sides of the hyperbola. If you find the midpoint of the foci, that is called the center. Again, the center is another kind of imaginary point, kind of like an ellipse. It doesn't go through the center. That's right in the middle of your shape. So in this problem, it's not labeled, but the center would be right about there. Okay, and now yesterday we had a name for the axis that was perpendicular to the major. What did we call that yesterday? Yep.
Minor axis.
Minor axis. Okay, today it's called the conjugate axis. So the conjugate axis is the name of the axis that goes through the center, and it is perpendicular to the transverse axis. Now, technically, you've already seen a hyperbola. Okay, we've done hyperbolas before this year. We haven't done them the way we're doing them right now. But when we graph something like this, 1 over x, that's a rational function. That is a hyperbola. The difference is this hyperbola is on an angle. It's on like a 45-degree angle. The transverse axis would look something like this. We're not doing transverse axes that are going to be on an angle. The two choices you're going to have for transverse axis is one that's horizontal or one that's vertical. But technically that is a hyperbola. You can draw a hyperbola at any angle that you want. But we're not. The two parts of the hyperbola, okay, those are called branches. So generally, we'll either refer to it as like the left and the right branch, or the top and the bottom branch. Depends which way the transverse axis goes. And then lastly, where the transverse axis crosses the hyperbola. So in other words, like right about there, and right about there. Those 2 points are called the vertices. Okay, so if I drew a hyperbola like this, and drew in my transverse axis, that's a vertex, that's a vertex. If I drew it this way, that's a vertex, that's a vertex. So think about where the vertices are and where the foci are. That's a vertex, that's a vertex. That could be a focus, that could be a focus. Now think about how that compares to an ellipse. What would, let's do this, where the major axis crosses the ellipse, what do we call those 2 points? Yep, those are the vertices. V1, V2. Where are the foci in relation to the vertices when you're looking at an ellipse? Yeah?
They're between the vertices?
They're between the vertices. This would be F1, this would be F2. So look at the difference between the vertice and the foci. In an ellipse, the foci are inside the vertices. In a hyperbola, the foci are outside the vertices. And that's how everything is today. It's like everything is just the opposite of what it was yesterday. Any question on that? So those are all the different terms that we'll use when we talk about ellipses. I mean, hyperbolas. I'll do that a lot today. Okay, so now let's look at the equation of hyperbola. I might have mentioned it yesterday. Does anyone remember if I said it yesterday what the one difference was going to be between the equation of an ellipse and the equation of a hyperbola? Yeah?
The plus between x and y is going to be minus.
Yeah, the plus is going to change to a minus. So if this equation looks very familiar, it should. It's almost the same equation as yesterday. In fact, the A and the C still mean the same thing. A is the distance from the center to the vertex. C is the distance from the center to the focus. There's no change in what A and C mean. It's still equal to 1. You still have an x and a y variable, both to the second power. But it's a minus sign instead of a plus sign.
It's not working.
Now, does anyone have a guess what's going to change when the transverse axis is vertical? Yeah?
The denominators?
No, not the denominators. So, yesterday, the way that we figured out which way the major axis went is we looked at where A was, because A was always the bigger number. That's not at all how you do it today. The way you do it today is you look at the variable that is positive. You're going to have two variables that are squared. One is going to have a negative in front of it. The other one will not. Whichever one is positive, that letter is the direction of the transverse axis. So what's going to change place today? The numerators. Okay, the numerators will switch places. Positive x, transverse axis is going in the x. Positive y, transverse axis goes in the y direction. Notice the other thing that's a little bit different is the formula that relates A, B, and C. It's always c squared on one side and then a squared and b squared on the other. But the way I remember it is whatever symbol you put there, use the opposite one in your formula. Okay? So today it's c squared equals a squared plus b squared. Right, any questions on that part? Now, there's one more thing with a parabola. Or a hyperbola. Sorry. If you look at a hyperbola, I have this one up, so let's look at it for a second. What does that hyperbola have? And we talked about these a lot. There's a special feature in that graph that if you were going to describe that hyperbola, you'd want to describe these.
Vertical asymptote.
Yep, and?
Horizontal asymptote.
Right, it has asymptotes. Now this one is on an angle, so our asymptotes would be vertical and horizontal. We're not drawing hyperbolas on an angle. We're drawing hyperbolas that look like this. So what we're going to have is an asymptote that's like that, and an asymptote like that. Those aren't drawn perfect, but the idea is this will continue to get closer and closer, closer and closer, closer and closer, closer and closer. So that X shape that the asymptotes are going to make, that's different than yesterday. Ellipses didn't have asymptotes. But the X shape is going to help you to make your sketch because it's going to give you a region to put the branch in. Okay, so we have to find the asymptotes. So how do we do that? Every hyperbola is going to have two asymptotes. When your transverse axis is horizontal, the slope of the asymptote is going to be b over a. What I really remember is this one. When your transverse axis is vertical, it's a over b. So I remember that, VAB. Vertical transverse axis means the asymptote has a slope of a over b. So that, that's kind of how I remember it. And then horizontal is b over a. Okay, so we haven't done the vertical one yet. I'm gonna give you a chance to write that one down in a little bit. But the only difference between this one and the vertical one is look at the letters in the top. Now the y is positive and the x is negative. That's the only change. And when we write down the slope of the asymptote, vertical is a over b, VAB. We'll practice a few examples first, and then we'll try it. Okay, so same thing I wrote yesterday. A is the distance from the center to the vertex, and C is the distance from the center to the focus. I don't know if we're going to come across any examples where A would be a negative, but if it is, it's a distance. We always want to think of it as a positive. And then B, well, B doesn't really have a visual that I can describe to you on the sketch. Not like yesterday. Okay, yesterday, that was easy. Center to vertex was A. Center to focus was C. Center to minor axis up there was B. Those were our three letters. But today, we're just looking at the A and the C in the picture. So here, A would be center to vertex, and C would be center out to the focus. That's pretty much it. That's everything you need to know about hyperbolas. So now we'll just try examples. Any questions on any of that information? So, same kinds of questions we had yesterday. We're going to start with one that says find the equation and make a sketch. So let's start to see if we can identify the letters A, B, and C. Any one of those three letters up there that you think we already can figure out? Yeah.
A is 2.
Yeah, A is the distance between the center and the vertex. A is 2. Any other letter we can figure out?
C is 3.
Yeah, C is 3. It's the distance between the center and the focus. And now B has to be found indirectly. What's the formula that connects A, B, and C for a hyperbola? Yep.
C squared equals A squared with B squared.
A squared is B squared. Yep. So we've got 9 equals 4 plus B squared. So that means B is going to be, yep, root 5. Right, let's set up our formula. So this time, when you're writing the equation of a hyperbola, you can start out with this. A squared is always first, always in hyperbola. B squared is always second. There's a subtraction sign, and there's an equals 1. What you have to figure out now is whether the x squared is positive or should the y squared be positive. So if you're not sure, let's graph these points, which I'll save those for a minute. These. So the center is 0, 0. You have a focus at 3, 0. Where would the other focus be if we had one at 3, 0? Yep.
Negative 3, 0.
Got to have one symmetrically. So there's your other focus. And you've got a vertex at negative 2, 0. And if you got a vertex at negative 2, 0, you have another vertex at
2, 0.
positive 2, 0. So knowing that our hyperbola is going to wrap around the foci, just really bad sketch. It's going to be something like that. Which way does the transverse axis go? Yeah.
Horizontal.
It goes horizontal. Remember, it's going to traverse. It's going to go across the branches. So it's going to be horizontal. All right. So if it's horizontal, what letter represents horizontal on a graph?
X.
X. We want the X positive. X squared, Y squared. Now fill in A and B, and you'll have your formula. So we've got X squared over 4 minus Y squared over 5. I am going to solve that for Y and try to graph it in a little bit. But I want to do our sketch first and then see if our sketch matches what we do on the calculator. Okay, asymptotes. Horizontal. What is the slope when you're doing horizontal asymptotes? Yep. B over A. It's a positive and it's a negative. So positive B over A and negative B over A. So let's write that down. B is root 5. A is 2. So root 5 is not going to be the nicest number for a rise over run in the slope, but we'll work with it. B over A plus or minus. Those are your asymptotes. Okay, so I want to do a better sketch than that, so let's move those off. Okay, where's the y-intercept of my asymptotes? Yeah. Yeah, it's at 0. Yeah, it's at the origin. So until you shift the center, we don't have to worry about a y-intercept on the asymptotes until we shift. So root 5, what's that? It's about probably about 2.3 maybe? 2.23? Okay. So we've got, that's our rise and run. Okay, so if I go up a little bit more than 2 units, and then right 2, puts me at about 2.22, and then I'm going to do it again. So I'm going to go up to 4.4. So 1, 2, 3, 4.4, and then right 2 more. And then I'm going to do the same thing the other way. I'm going to go down 2.2 and right 2. So I'll go down 2.2, right 2, about right there, and then go down 2.2 again, and right 2. So I've already drawn the lines. As long as I did my points right, they should match up. Yeah, pretty close. So there's your, that one I'm a little off, but there's your asymptotes. And now we're going to draw in the branches. Okay, remember, you're going to go through the vertex. You're not going to go through the focus. So it's easier to draw if it's not as big on the screen for me. So let's do it like this. It's going to go through the vertex, get closer and closer. And the same thing here. Stay close to the asymptote, curve away, and then start getting closer. So that's a picture of what it should look like. Now, is this graph a function? No. So when I try to sketch it, it's going to fail the vertical line test, which means I can't really sketch it. But what I can do is I can sketch the top part of each branch and then the bottom part. So let's solve that for y, graph it, and see if it matches. Let me do that down here. Square root of 4. What would be my first step to get y by itself in that equation? Yep.
Subtract x squared.
Subtract what?
X squared. Wait, again, x squared.
Getting y by itself.
Right, subtract x squared. 4.
Yep. Subtract x squared with the 4. So all right. What would be my next step? Yep.
Multiply by 5.
I'm going to multiply, yeah, by 5. I'm going to do -5 so that way I cancel the negative at the same time. So multiply by -5. That's going to be gone. You don't have to distribute it. Just another place if we could make a mistake. And then what's the last step? Yep.
Take the square root.
Take the square root. So square root is going to cancel the exponent of 2. And that's how you're going to get the top and the bottom part of each branch. Square root of. Okay, so if you take that in carefully, you should get a hyperbola that looks just like that. Let's try. So we got y equals square root of -5, parenthesis. I'm going to do another parenthesis because I have x squared over 4. Close parenthesis for my fraction. Let's close it for my distributive property with the -5. I think I got everything typed in right. We're going to find out. And then I need the negative of that, so I'm just going to do negative variables function, and then I don't have to retype the whole thing. That's it. So let's do zoom 6. So there's the top part of the left and right branch. There's the bottom part. They don't connect because it's getting very steep right at the vertex. Let's see if that looks like what we've got. Yeah, looks pretty good. The vertex is at 2, 0 and -2, 0. Seems good. Any questions on that? So that's how you can sketch a hyperbola on the calculator where the branches are opening left and right. It's the only sketch I'm probably going to do today. Oh, and asymptotes. Let me throw those in just to make sure they look good. What were they? Positive or negative √5 over 2x. So let's do √5 over 2x and negative. Let's do it like this. Negative √5 over 2. So if we did this right, those asymptotes should look like they're getting closer and closer to each branch, but never touching it. And yeah, looks pretty good. Any question on that? All right. For this one, I want to discuss it. What is A in this case? Yes.
4.
A is 4. How do you know that?
Because it's the square root of a larger denominator.
Not quite. A is 4 though. It's not because it's the square root of the larger denominator. Yep.
Because it's under the positive number.
Yes, it's because it's under the positive. How do we identify where the A is? guess you could say because it's under the positive, but I'm thinking of an easier way. Yeah.
First one.
First denominator. Yeah. The first denominator is A, second denominator is B. So I kind of just told you how to find B. What's B?
2.
2. But if you want to find the foci, you need C. What's the formula that connects A, B, and C? Yeah.
C squared equals
C squared equals A squared plus B squared. That's going to be the square root of 20, which is 4 times 5. So that's 2 root 5. And yes, you want to reduce that as much as you can. All right, so C is 2 root 5. Okay, what, well, I'll give you the order you want to do things in. Always do these two things first. I don't care what order they write them in on paper. Find the center and the transverse axis first. Where do you think the center is for that one? Yep.
0.
That's how you'd write the center, just 0?
0, 0.
Right, got to put it as a coordinate, 0, 0. You'll know when it's not 0, 0 because this and that are going to look just like an ellipse. They're going to have the minus or the plus with it. If there's no minus or plus, so we're going to put the center at 0, 0. Which way does my transverse axis go? Two choices. Yep.
Horizontally.
How come? Yep. Because x is the positive variable. So we need to get the idea of bigger denominator out of our head completely for hyperbolas. Doesn't matter. X is the positive. Okay. How many units away from the center are the vertices? Yep. 4. And which way?
Left and right.
Left and right. So what would be the two coordinates that are 4 units left and right of that?
4, -0. Negative 4, -0 and 4,
Yep. I can use the same shortcut when the center is not shifted that I did yesterday. The numbers are going to be symmetrical, so I can use plus or minus. How far are the foci from the center? √5. So we know they're 2 √5 and they're in the same direction as the vertices. Can someone give me the 2 foci coordinates? Yep.
Negative 2 root 5, 2 root 0, and 2 root 5, 0.
Yep. So positive or negative. 2 √5, 0. And one more thing we need are the asymptotes. Just need to know what goes in that box. What's going to be the slope or slopes of my asymptotes? Yeah.
1/2 negative half.
Yeah, it's going to be b over a, which is 2/4, which reduces to 1/2 and negative 1/2. That's the extra thing for today. That's the asymptotes. So now that's another piece of information they could give you that now you would have to work backwards from the slope to figure out the A and the B. And if you look at it, you might think, well, wait a minute, could the A be 1, or the B, since B's in the top, could B be 1 and A be 2? No. You'd have to know that that fraction had been reduced to get to that point. And the only way they would know that is if they gave you another piece of information. So this tells you that A is 4, and if you have a fraction, B over A, and the A is supposed to be a 4, then you can work backwards and figure out what the B value should be. So you might have to work backwards from the slope. Any question on that? But it does get a little tricky when they reduce the slope, because then the numbers they're giving you are not the correct numbers, they're the reduced numbers, but they got to give you something else to help you. I couldn't just give you asymptotes and say find the equation. That's not enough. Okay, so let's discuss this one. What's wrong with that equation? Yep.
It doesn't equal to 1.
It's not equal to 1, so how would we fix that?
You divide everything by 9 and -4. And, well, no, just divide everything by 36.
Yeah, just divide everything by 36. Yep. When you divide x squared by 36, 9's going to cancel into 36 4 times. When you divide 4 by 36, 4 is going to cancel into 36 9 times. And now we have 1. Okay, let's go through and do what we did last time. What's the A value in this one? Yep, 2. A is 2. B value? Yep, 3. And what about my C value? Yes, root 13. Perfect. All right, 5 things. Let's start with the center. Okay, where's my center? Yeah. 0, 0. What is the direction of the transverse axis? Horizontal, because the x is positive. Vertices. Where are my vertices going to be? Oh, I mean, where are my vertices going to be? Yes, because they're left and right. Yeah. 2 units left, 2 units right. Where are my foci going to be? Yep.
Plus minus root 13, 0.
Yep, and that's how you're going to just leave it. Don't worry about simplifying. Asymptotes. What's going to be the slope of my asymptotes? 2 slopes. Yep.
3 over 2.
B over A. Yep, 3 over 2. This time, 3 over 2 doesn't reduce. So those actually are your values that you would need. Okay, any questions on those 5? Okay, so I'll give you a minute to copy that. It's the same formula. I already showed it to you, but you haven't written it down yet. Now we've made the y positive instead of the x. That means the transverse axis is going to be vertical. All your important points now are going to be above and below the center. And your slope, vertical, A over B, VAB. Vertical is A over B. Still equal to 1. Still have the subtraction sign. A squared is first, B squared is second. None of that changes. The formula that connects A, B, and C, that doesn't change either. Okay, so take a second to see if you can get that equation in the right format. Make sure you get it equal to what it's supposed to. See if you can identify the A, the B, and the C. And then write down the vertices, the foci, the center, transverse axis, asymptotes should be there too. Yep. Okay, so take a minute to see if you can figure out those 4 things. The equation, if you can't read it, it's y squared minus 4x squared equals 4. Okay, what did we find you had to do first in this equation? Yep.
Divide everything by 4.
Divide everything by 4. So you're going to get y squared over 4. 4's are going to cancel with the x, and they're going to cancel on the other side. What's the A value here? Yep. 2. B value? Yep. 1. And C value?
Root 3.
Root what?
Root 3.
Not for hyperbola. This one looks more like the Pythagorean theorem. Yep. Root 5. Okay. Where's my center? Yep. 0, 0. Direction of the axis. Yep. Vertical, because the positive letter is y. What about my vertices? What are those going to be?
0 plus or negative 2.
It's going to be up and down 2 units from the origin. What about my foci? Yep.
0 plus or minus root 5.
0. So again, up and down. And what about the slope for my asymptotes? Yep.
Y equals plus or minus 2x.
Yep. Vertical is A over B. So plus or minus 2x. Okay. That's everything. Any question on that one? Let's just pick one of these. I don't think we need to really do both. We haven't done as much of writing the equation. Let's do 5 and then we'll skip 6 and we'll do the shifting after that. Okay. What do we have to identify first to find the equation? First 3 things we have to figure out. Yep. A, B, and C. A is the distance between the center and the vertex. C is center to focus. One more letter we need to be able to write the equation, and that is B. What's the formula that connects A, B, and C? Yep.
C squared equals x squared plus b squared.
C squared, A squared, B squared. That's going to give me square root of 5. Okay. What would be the direction of the axis? Yep. Yeah, look at your points. They all have an x value of 0. One of them is up 2, down 3, up 3. They're all vertically lined up. That means we want a y positive. We want the x negative. We always put a squared first, b squared second. Any question on that? All right, so we've done a lot of, I give you the equation, you discuss it. I give you the discussion part, you give me the equation. We did a graph of one. So now the last thing is to look at the shifts. Okay, they give you this whole table and all this stuff in the book. I don't really memorize any of this. The only part of this that I look at is right there. It's exactly the same equation as what we had before, except now you've got a minus h and a minus k, and that is the coordinates of the vertex. Up until now, these have been 0, 0. Now they're not 0, 0. The slope of your asymptotes, it's exactly the same. When it's horizontal, it's b over a. When it's vertical, it's a over b. But look at how they wrote the equation. That's point slope form. That's not y equals mx plus b anymore. That's point slope. The reason they're using point slope is because the asymptote has to go through the center. Whenever you draw a parabola, the asymptote goes through the center. How are you going to make it go through the center? You're going to use a point slope. We already know what the slope is supposed to be. We just have to force it to not go through the origin anymore. So just think of that as y minus y1 equals m times x minus x1. Here's your y1, x1. That's your point. And there's a sketch of everything that's happening. So let's try one where we work with something that's been shifted. Let's do one where I give you the information and you give me the equation. Okay, how many letters are there to find? Yep, 5. Just like an ellipse, H, K, A, B, C. Four out of 5 of the letters you should be able to find what I call by like inspection. You can just look at it and pretty much tell what they are. One of them has to be found with a quick calculation. Anybody tell me one of the letters that we know? H is from the center. H is 1. How about another letter? Yeah. K is negative 2. All right. How about another letter? Yep.
C is 3.
C is center to focus, and the difference between 1 and 4 is 3. Yep. And one more letter. Easy. Yep. A is the distance between center and vertex. Difference between 1 and 3 is 2. One more letter we need is B, and we'll get that with Pythagorean theorem. Well, I shouldn't say Pythagorean. It's not Pythagorean theorem. It just looks like Pythagorean theorem. So C squared equals A squared plus B squared. What is B? Yep. Root 5. Okay, now we need our pattern. Well, I know it's going to have an A squared, a minus, a B squared, and a 1, and squared, squared. But I don't know what else until I think about it a little bit. Which way does the transverse axis go in this one? All your y values are at -2. and they have different x values. Write 1 down 2, write 4 down 2, write 3 down 2. They're all going to line up how? Yep. Horizontally. That means which letter should be positive?
X.
X. Y should be negative. X always goes with H. Doesn't matter which one you're doing. X with H. Y always goes with K. Okay, so X minus H, Y minus K. Now we just fill it all in. Let me go like this. So X minus 1 over 4. I'm going to have Y minus 2, so it's going to be plus 2, over B squared, which is 5, equals 1. Okay, so they said find the equation. They didn't ask for the asymptote. I'm going to find the asymptote because you might want to know how to do that. So you're going to use this formula. It's the point slope form of a line. What's going to be my slope when the transverse axis is horizontal? What letter over what letter? Yep.
B over A.
B over A. So my slope is a root 5 over 2. And what's the point that I want to force my line to go through? Got my slope. But it has to go through the point, yep,
1, negative 2.
1, negative 2. So you're going to fill in minus 2 and minus 1. It's not y equals mx plus b, but it's the point slope form of the asymptotes. Any question on that? So that's the end of Conics. Okay, so homework, it's 13 to 16, that's all. 17 to 21 odd, 29, 31, 37, 41 odd, and then 47.